So we may have one more thesis defense schedule, but everything else is basically what we saw on the original schedule at this point. So, and that's mainly because we have a holiday. One of the Wednesdays we have off, and then we decided not to schedule anything the day before Thanksgiving because most people don't. They go off and do their Thanksgiving things that weekend. So we're getting close to the finish line. So hopefully your morale is high. Some of you are really close to a real finish line, like going to graduate and stuff like that. So that's super exciting. So now that it has clicked over to 1201, I think I will offer up an introduction for Dr. Russell, who needs no introduction for many of us who hang around environmental studies because he's ever present in the graduate program as a graduate advisor. So those of you who are in the graduate program have taken a course or two from him. But let me just give a brief intro to what he's going to talk about today and what he's done before coming here. So Dr. Russell's research focuses on conservation and restoration of forest communities and the effects of logging on coastal redwood forests. If you look at his website, you will find an extensive publication record. I had no idea how many, so many there, a very long list, with research on many types of California ecosystems, so not just redwood forests, but also I saw stuff on dunes, coastal dunes. I saw stuff in the Sierra Nevada. So he understands the California, the diversity of California systems quite well. His research has appeared in journals such as Forest Ecology and Management, Landscape Ecology, Madrono, Fire Ecology, and Ecological Restoration, among many others. He holds a Ph.D. from the University of California, Berkeley in Environmental Science, Policy, and Management. He has a master's degree from Environmental Studies from San Jose State University. There we go, so some of you may have that too. And an undergraduate degree from the University of California at Santa Cruz in Plant Biology. And prior to coming to San Jose State, Dr. Russell has worked at the USDA Forest Service, the USGS, as well as California State Parks. So a lot of different roles in important institutions that are helping govern a lot of the systems that he knows a lot about. So please join me in welcoming Dr. Will Russell to the seminar.
Thank you, Dustin. You're very welcome. Well, it's great to see all you guys. I think I know everybody here, and it's really a pleasure to be able to share the kind of work I do with you guys. So the talk I'm going to be giving today is going to be a little bit upside down and backwards, because that's just like how I like to do it. But I'm going to be giving you some results from some older projects first, and then I'm going to be giving you some methods and questions for a project that I'm moving into right now. So the two do fit together. If you have any questions at any point throughout the talk, please feel free to interrupt, raise your hand, and I like to have everything be clear as I'm going along. This particular talk is about Trillium ovatum, which is one of my favorite species, and in particular its relationship to coastal redwood forests and their recovery. So this is our Trillium ovatum here in the foreground with a nice redwood behind it. Okay, I don't have to walk over there. Dealing with new technology here. All right. So, why redwoods? Why should we care about redwoods? So I want to talk about first is the value of living redwoods. There's a value associated with dead redwoods as well, and that value has led to the primary use of redwoods, that is timber harvest products. But they do have some values as living organisms and as living systems. So the first one I want to mention is watershed. If you look up in the photo here, this is a picture of Fall Creek, one of the Fall Creek Springs tributaries up near my house in Felton, California. And this is a picture that was taken about 2 weeks ago, before the rain and after 3 years of drought. The springs are still bubbling. Somehow these forests are able to hold water in ways that other forests cannot, other systems cannot in California. So they provide a really important service in terms of collecting water from the atmosphere and then holding that water in their soils as well. Pretty amazing stuff. Wildlife habitat. I know we have some bird people in here. There are a couple of important birds that are associated with coast redwood forests and with old growth forests in particular. Anyone name this one? Extra credit? Come on.
Owl.
It's an owl. Good, good.
It's an owl. It's an owl.
Half credit.
Spotted owl.
Spotted owl. Okay, we're almost there.
Northern spotted.
The northern spotted owl. That's right. Endangered species, the northern spotted owl, which apparently only nests in old-growth forests, Doug fir forest, redwood forest, etc. And then this one. Okay, this is our advanced questions. Anyone know this bird?
Marbled murrelet.
Who said that? All right. That's got marbled murrelet. And the marbled murrelet is a seabird. And for many, many years, no one could figure out where these birds nested, because they didn't see them on islands, they didn't see them on beaches. Finally, a researcher up in Big Basin State Park actually found the first marbled murrelet nest up on a huge lateral branch of a old-growth Doug fir tree. It turns out they only nest on huge lateral branches with moss growing on them on old-growth trees, primarily redwood and Doug fir. So they need old-growth forests next to the coast. This is a coho salmon, and a whole lot of variety of different salmonid species rely on redwood forests and coastal forests in general. Deforestation has a very negative effect on these species by raising stream temperatures, etc., and adding silt into the stream systems. And not an endangered species, but certainly a species that is associated with coast redwood forests. So I didn't want to forget about our little sluggy friend. And then the species that sometimes we don't think about that much, but it's growing in importance in terms of its relationship with redwood forests, particularly with what's happening around this Christmas this year, is of course Gila. And for those of you who don't know, the forest moot of Endor, if you ever want to visit there, it's actually Prairie Creek State Park up in Northern California. Those are, in fact, redwood trees. All right, so importance of living redwood trees as opposed to dead redwood trees. Something that's becoming more and more apparent is that redwood trees may be our best bet for sequestering carbon terrestrially. There's been some excellent work going on with a team of scientists, the Redwood Climate Change Initiative, which is funded by the Save the Redwoods League, and they have been working meticulously with the help of millions and millions of dollars to measure every leaf, stem, and twig on redwood trees and across the range to see how big they are, how much mass they hold, and how quickly they grow. At what point in their lifespan do they grow the fastest, etc. And they have found out some very interesting things. First, that ancient redwood forests store about 3 times more carbon than any other terrestrial system. So if we're going to sequester carbon somewhere, why not choose this forest type? And second, that 2 mature redwoods, 2 of the biggies, sequester as much as 1,600 tons of carbon, which is as much as you or I will use in our lifetime. So think about that. There's a pretty good argument, if you think about this, for really preserving redwood forests. So this is our choice, really, with redwood forests. We harvest this, we use the products. After about 50 years, what do we do with redwoods? We mainly build fences these days and decks. We don't build houses out of them anymore very often. So this sort of material decays rapidly. When it's decaying, what's it doing to the carbon? It's releasing, right? So after 50 years at best, you've released all that carbon from that tree. Or you keep it living in the tree, and it keeps sequestering carbon year after year. And the interesting thing about redwood trees is apparently they sequester more carbon every year than they did the year before, no matter how old they are. There's an old scientific misconception that as forests get older, they reach a plateau where they stop sequestering carbon. That appears to not be the case. The older the tree is, not only the more it holds, but the more it adds every year. So older forests are better for sequestering carbon. So I'm just going to say it. Why not lock up all of our redwood forests, stop harvesting them, and use them as a tool against climate change? I can't see a good argument for it. Against it, I can see a lot of political arguments against it, a lot of economic arguments against it, but in terms of science, it seems like it would be a good idea. Okay, so those are some of the positive values of living redwood trees in terms of science. And then there's these other reasons, like people like to have redwood forests alive. For recreation, for inspiration, to go look at these giant trees. And they have been providing inspiration for people for many years. Folks like this guy here, anyone recognize that one? I know, it's a blurry picture. That's John Muir at the dedication of Muir Woods up in Marin County. With some of his buddies, Teddy Roosevelt, Gifford Pinchot. They're standing with one guy between them, maybe to keep the blows from landing. And then this one here, anyone who's taken my class probably knows who that is by now. If not, Judy Berry. So people have been inspired to the point where they feel like these forests are, in a sense, part of their family, and they feel compelled to protect them at any means. All right, so that's my argument for why we might leave them alive. So what's the deal? Why am I so worried about that? Well, there's a history here. I'm talking about redwood forest recovery. So the question is, oh, thank you. The question is recovery from what? This is a timber harvest that occurred about 1856 in Mendocino County in the Big River watershed. You can see the scale of it in terms of how many trees are down. Essentially a clear cut, though in those days what foresters would do is just take the good trees and leave whatever didn't look like it was going to be good at the mill growing, but a lot of those were damaged. And then you can see the scale of the trees that were taken out by looking at this little guy in the corner. Anyone tell what that is?
You?
That's a human. Yeah, that's a human being. So not only was the scale of it enormous on the landscape, but the scale was enormous in terms of the trees they were taking out. And this was sort of a common situation in coast redwood forests across the range during that period of time, the 1850s. Technology was limited to the point where most of the harvesting was happening along rivers and stream channels. But as our technology got better, harvesting expanded into virtually every area of the redwood forest. We had Caterpillar logging and chainsaws coming in the 1950s and 60s. There was virtually no place that was safe. And by the 1980s, we had the end of the old-growth redwood forests, with only about 3 to 5% left that are protected in reserves. Everything else was cut and milled. So not very much of it left. So what's going on now? We had a kind of a lull in redwood logging starting in about the 1980s and 90s because of the end of old growth. A lot of the mills that were running up to that point were designed only to mill old growth. And so when the old growth was gone, the mills shut down. Operations were moved for companies like Georgia Pacific, Louisiana Pacific. They moved a lot of their operations to Canada to attack the boreal forests, to Siberia, to other continents, other places where they could find some virgin timber. So there was a little bit of a lull in the 80s and 90s, and then things started to pick up again as some of these new timber companies, which are billed as being more sustainable, the Mendocino Redwood Company, the Humboldt Redwood Company, these are all companies that are owned by the Fisher family, the Gap people, Gap clothing store people. They got into timber management. And so what they got when they purchased these old timberlands was a really heavily managed landscape, an area that had been hammered. There was nothing growing there but small second growth trees, essentially. Yeah?
When was this?
This is in the last couple of decades. So I think, I'm trying to remember when Mendocino Redwood started in the late 90s, and then Humboldt Redwood just a little bit after that. So this is current, what we're looking at here. This is Mendocino County. And this is the way timber is harvested now. What's different about what's happening now, what happened in the 1800s, is that the whole thing is happening on a palette of heavily disturbed stands. Small trees that are just barely trying to recover. And so we have this patchwork of harvesting. In the modern speak, in our modern double speak, this is not clear cutting. So we're not doing clear cutting anymore in Humboldt and Mendocino County. What we're doing is small group selection. So a small group could be 5 acres, 10 acres, etc. Within that 5 or 10 acres, all the trees are cut down. But it's not clear cut, so we're doing sustainable logging, we're doing selective logging, okay? But you can see what the effect is on the landscape. Patches from the stuff that was just recently cut, stuff that's just starting to come back. There's a few nice areas around streams because by law you're not allowed to harvest right inside of stream corridors. So some things have improved in terms of timber management that way. But unfortunately, since these stands were so disturbed when this sort of selective management started on them, they haven't really had a chance to recover. So we have our small group selection, which along with that goes some industrial practices like herbicide application. There's a lot of controversy in Mendocino County about that right now, what they call hack and squirt, where all competing species are cut and then painted with herbicides. That can be damaging to aquatic systems and maybe other systems as well. And then we have these new types of applications of silvicultural techniques, restoration logging and fuel treatment logging, which is something we all have to keep our eyes on because restoration in forest has started to mean an excuse to log. And fuel treatments in forests have started to mean an excuse to log. And this has been supported by state policy. It's certainly supported by the timber industry and has led to areas being entered for logging that had not been entered for a long time, including the state parks and the national parks. So a few minutes ago I talked about this 3 to 5% that was protected. Well, even that protected area now is at risk because of restoration and fuel treatment logging. And then we have this, this carbon credit thing, which seems like it'd be perfect for the redwoods, right? Here's a system that can collect 3 times more carbon than any other terrestrial system in the world. Let's put our money behind that and pay to get these guys off of the chopping block so they can grow. Well, in fact, what's happened at the state level is that carbon credits, the carbon credit dollars have been going to the timber companies directly to the tune of millions of dollars to support what's called working forests. So the idea is, well, a forest that's being harvested sequesters more carbon than a housing development. So we will give money to the timber companies to keep harvesting timber so that they don't turn all their lands into housing developments. There's way, way, way too much timberland to turn into housing developments, first of all. And most of where the timberland is isn't where anyone wants to build a housing development. So it's a false argument. What it really turns out to be is a huge subsidy for the timber industry and a real failure of our leaders to tackle the problem of climate change. Okay, moving on. So that's kind of the story of the damage. So this is a talk about recovery, though. So what are we talking about? Recovery to what? From what? We understand that now. It's from these harvested stands. To what? To something called a mature late xeral forest. Something similar to the old growth forests that were destroyed in the past. So what is an old growth forest? First thing, I feel like I need to define what old growth means. Old growth is a word that was actually coined by loggers, not by ecologists. And what it meant was the stuff that was there when Europeans got here. So the naturalist forest that they'd seen. Forest that was essentially undisturbed by humans and unmanaged. Once you cut that forest down, you don't get old growth back. Because you can't roll back time and never have entered it and cut it before. So old growth is a one-time thing. It was here when we got here. Once you cut it, you don't have it anymore. However, when forests recover, they can take on some of the features of an old growth forest. That's what we call these late xeral features. And I've listed some of these up here. Basal hollows. This is a basal fire hollow here on this redwood tree up in Mendocino County. Large lateral branches, There's one up here that doesn't show up very well in this picture, but that's something that happens with old growth trees as their crown starts to develop, which is where a lot of the carbon turns out to be in old growth trees. Large snags, that's big dead trees on the landscape, which are excellent for wildlife habitat. And a variety of associated species, understory species, wildlife species, fungi, invertebrates, etc. So my point being is not just big trees. Big trees often are part of a old growth redwood system, but they're not always part of an old growth redwood system. Sometimes it's small trees. And sometimes it's really the diversity of different types of species and trees on that landscape that's important. Okay, so what I'm getting into now is some results from a variety of subjects, a whole series of research projects that were done by myself and some of my graduate student associates over the years. And so I'm going to be giving you some results from those as kind of a lead-in for the next project that I'm working on. And all these research projects together I like to call natural recovery of coast redwood forests. And what I found when I was a graduate student at Berkeley was that people were studying redwood forest recovery, but they were only studying it under new types of manipulation. So here we have a redwood stand, a second growth stand. What can we do to make it produce bigger trees faster was generally the question. So if we cut it this way, if we thin it that way, is that going to make more trees faster? No one was looking at what happens if you just leave it alone. And so I thought it was really important to ask that question to see what does a natural regeneration look like, what does a natural recovery look like, so we can see if there are any problems in there that we need to address. And if there's not any problems, then maybe we don't need to do anything. Starting in 1999, I was funded by the Save the Redwoods League and have been very fortunate to receive funding multiple times to support this kind of work. Here's a list of some of my graduate student associates. I felt like they deserve mention for this because they did a lot of the grunt work, and we're talking about thousands of hours in the field, meticulously measuring trees and all the little plants that are growing on the forest floor. And all the results I'm going to show you come to a large degree at their expense. All right, so this research that we were doing it on this model of forest recovery that was written about by a guy named Oliver in 1981. And he suggested these 4 steps of forest recovery. The first being stand reinitiation, that is, how and when do the trees themselves come back? The new little trees, how do they come back? Are they going to come back? Stem exclusion, which is a tricky bit that I'm going to get into. But basically that means when trees do come back, they usually come back in numbers too great for that landscape to support. So something needs to happen for them to thin out for that forest to be healthy. Understory initiation. This is a big focus of this talk because this Trillium species we're talking about is understory. So how does the understory respond to recovery? And then old growth he puts on the end. I wouldn't put that on the end personally because I don't think we can get old growth again. What I would say is late cereal forest or something like that, because you can't replace old growth. Okay, so let's start with stand reinitiation. In coast redwood forests, unlike any other major timber species, this species is clonally reproduces for the most part. It can reproduce from seed, and it can reproduce from clonal sprouts. These are clonal sprouts here coming out of a stump. And when you cut a tree down, or if it falls down naturally, you'll have literally thousands of little sprouts coming out from the stumps. So no problem there. Plenty of stand reinitiation. And loggers know this. They're very happy managing redwood because you don't have to replant it. You just cut it down, you walk away, and woo, thousands of sprouts. Yippee. So no one's concerned about that stage. The next stage is a stem exclusion stage. And in some forest types, this can be a real issue. In the Sierra Nevada, for example, you have the mixed conifer forests where you have, let's say, a stand replacing fire or a clear cut. After that, you will have thousands of little seedlings coming out from seed, and they will come packed together, and they'll be so densely packed together that they won't be able to grow. None of them will have enough room to really grow, and they'll start dying back. They'll become what's called etiolated, where they'll be very long and skinny and have a little bit of green on the top. That can go on for decades. And in the right conditions, those dry out, they get attacked by bark beetles, and you have huge fires and things like that. So it can be an issue in some forest types. I'm going to argue that it is not an issue at all in redwood forest types. We do not have this feedback where the stem exclusion stage doesn't happen, you get sent back to stem reinitiation. Because in coast redwood forests, we have a natural thinning that can happen. And it can happen for a couple of reasons. One, because of that clonal regeneration I've mentioned. If you think about it, all these stems, this is a stump here. These are some stems coming off of this stump that are probably about 40 years old. These stems are still connected to that old stump. So in a sense, they're not really separate trees, they're branches off of one tree.